This is for IB Math Studies 2, Chapter 20B, and we're going to learn about the concept of a limit and how to find it algebraically. If you read along with me on the packet that I gave you, the limit concept is central to the study of calculus. It allows us to talk about approaching a point without ever getting there. For example, I've given you the function of 1 over x, and if you look at the function, as x approaches negative infinity, the y values begin to get closer and closer and closer to 0. So this is like an asymptote. We've talked about these before. As x approaches positive infinity, the y value approaches 0. So another way of saying this is that the limit of 1 over x as x approaches negative infinity is 0. And the limit of 1 over x as x approaches positive infinity is 0. There are other limits that are important. Sometimes there are functions that actually have holes in them. They have a gap. And if this is at 2, and we'll call this 2, when we talk about the limit of this function, we would say the limit of f of x as x approaches 2. Well, as x approaches 2, y approaches 2 as well. And this is true from both the left and the right, so we could say that the limit there is equal to 2. Now, it's not crucial that you understand exactly what a limit is, but we use the concept of limits in order to help us find the slope of a curve. So when we talk about the slope of a curve at a point on the curve, we start by finding the average slope of the curve between 2 points. We did this yesterday. So here was point A, and here was point B. Then we moved the point closer. So here was point C. And then we moved the point closer again. Here was point D. And then we moved the point closer again. Here was point E. And as we move those closer and closer, the distance between those 2 points approaches 0. And at the moment that the distance between those 2 points is 0, the secant line that we'd been talking about becomes the tangent line, and then the slope of the tangent line represents the slope of the curve at that point. So let me say that again. As these points get closer and closer and closer to point A, which is the one that we were looking at, the secant line becomes the tangent line, and the slope of the tangent then represents the slope of the curve at that particular point. Okay, so go ahead and turn the page, and let's talk about how to find this, how to figure this out. So here we've got a curve, a quadratic, x squared, and we have a point A, which has the coordinates x and f of x, and we have a point B, which is a little bit away from point A, so it has the coordinates x plus h and f of x plus h. So we've drawn the secant line between those points A and B, and what we're going to do is we're going to find the slope of the secant line. Alright? Okay, so first we need 2 points, because in order to find slope we have to have 2 points. So what we'll do is we'll start with x1, which in this case I actually know the coordinates of that point. x1 is 1 and y1 is 1. Alright? But let's say we don't just want to find the secant that is made from A and B. We want to find any secant that exists out there. So remember, we're just going to go to point x2 is going to be 1 plus h, plus some distance. We don't know how far away it is. And then y2 is going to be equal to 1 plus h squared. And the reason it's equal to 1 plus h squared is because, remember, our original function was f of x equals x squared. And in order to find coordinate pairs, I pick an x value and then plug it in and get a y value. So if 1 plus h is my x value, then I just have to plug it into the function x squared. So 1 plus h squared gives me my second y value. Alright, now that I have 2 points, I'm just going to use my slope formula in order to calculate the slope. So first I need change in y over change in x. So that's going to be equal to 1 plus h squared, that's y2, minus y1 over x2, 1 plus h, minus x1. Alright, and now we're just going to expand and simplify. 1 plus 2h plus h squared minus 1 over 1 plus h minus 1. I can cancel out, simplify the top, and I get 2h plus h squared. Simplify the bottom, I just get h. Now if I factor an h out of the top, I will have 2 plus h, and I still have an h in the bottom. Those h's can cancel out, so I'm left with 2 plus h. So this is the general slope for any line on that curve, any secant line on that curve. And it'll depend on h, how far away the second point is from the first point. But think about this. Remember how we talked about we want point B to approach point A and get closer and closer and closer to point A. So if point B is so close to point A that the distance between A and B is actually 0, then H becomes 0. And therefore, the slope of the curve at x equals 1 is 2. So the slope of the secant, but in this case it's the tangent line, at x equals 1 is equal to 2. Alright? So that's what this says. As h approaches 0, the slope of the average slope of the function at a becomes the slope of the tangent to the curve at a, and thus the slope of the function at a. Alright, so now we're going to use that same method, and we're going to practice a few more of those. So the first thing that I have to do are identify some points. So x1 in this case is 3 because they told me, and y1 is going to be equal to 3 squared, or 9, because all I'm doing is I'm just plugging it into the function. Alright, x2 is going to be 3 plus h, because we need some other point that's on their curve, and that means that y2 is going to be 3 plus h squared, again because I'm just plugging it into our function. Alright, then we're going to use our formula, change in y over change in x. So we've got 3 plus h squared minus 9 over 3 plus h minus 3. So expand, 9 plus 6h plus h squared minus 9 over 3 plus h minus 3. Simplify the top, and you just get 6h plus h squared. Simplify the bottom, you just get h. Now I can factor an h out of the top, which gives me 6 plus h. Those h's cancel out. So in this case, we have 6 plus h. So as h approaches 0, the slope of y equals x squared at x equals 3 is 6. Alright, when you answer these questions, you don't necessarily have to write this, this sentence here that I'm writing. But what I'm doing right now is I'm pointing it out because I want to make sure that you understand what you're finding. Okay? So you found the slope of the curve at a particular point on the curve. You found the slope of the curve at x equals 3, and you found that that slope, which would be the slope of the tangent line, is equal to 6. Alright, let's move on and do the next one. Alright, so as h approaches 0, the slope of y equals negative x squared minus 2x at x equals 0 is negative 2. So on this curve, when x equals 0, the slope of the curve at x equals 0 is equal to negative 2. Alright, go ahead and pause the video here and try the last one on your own. When you're done, restart the video and you can see the answer. Okay, so here's the results for letter C. The slope at x equals 3 is equal to negative 4. If you didn't get that answer, chances are when you expanded this part of the equation, you actually didn't distribute that negative. You have to FOIL the 3 plus h, but then you also have to distribute the negative. So if you didn't get the right answer, just double check that work. Alright, that's how you find the slope of a curve algebraically. You'll see there's an assignment for you here. Go ahead to your book and practice.